So we're going to look at one problem on this video, and it's going to deal with the Hubble telescope, which was deployed in April of 1990 by the Space Shuttle Discovery. Now, the Shuttle Discovery, its velocity could be modeled by the velocity equation that we have here. And it's represented between t equals 0, so liftoff, and when the rocket boosters were jettisoned at t equals 126 seconds. And what we're going to do is we're going to use this velocity equation to estimate the absolute maximum and minimum values of the acceleration of the shuttle between 0 and 126 seconds. So the first thing we have to think about is when we want to find an absolute maximum or minimum, we work with the derivative of that thing. Because we want to find the absolute max and min of the acceleration, we've got to work with the derivative of the acceleration function. Well, since we started with a velocity function, we will take the derivative of that just to get the acceleration function. So when we take the derivative, the 3 multiplies that part out front, and we'll end up getting 0.003906 t squared. The 2 will multiply that negative 0.09 number, and that'll give us negative 0.18058 t. And then 23.61 t will just be 23.61. And our constant's derivative is 0. So this becomes our acceleration function. If we want to find the max or the min of the acceleration, we need to look at its derivative. So we'll call it a prime of t. We talked about a little earlier in the year that the derivative of the acceleration is actually the jerk. When we take this derivative, we'll end up getting 0.007812 t minus 0.18058. Well, we always want to check at our critical values, which is where the derivative doesn't exist or where the derivative is equal to 0. This is linear, so it's going to exist everywhere. To see where it equals 0, we'll just put 0 in for a prime of t. And all we'll do is we'll add over the 0.18 number and divide by the 0.007, and we'll get that t is equal to about 23.12 or so. If we now carry this down, we know to find the absolute maximum or minimum, we need to test the endpoint values and any critical numbers. Well, we're trying to find the maximum and minimum acceleration, so we'll test it in the acceleration function. We're going to have to plug in 0, our starting time. We're going to have to plug in our critical value, that 23.12, and we're going to have to plug in our ending value, the 126. When we plug in 0, we'll get 23.61. When we plug in the 23.12, again, we're plugging this into the acceleration function because that's what we're trying to maximize and minimize. The 23.12 will give us roughly 21.52 and some other stuff. And when we plug in the 126, we get 62.8685. So this is our absolute minimum acceleration, the 21.52, and this is our absolute maximum acceleration. And we should try to put some units on it. The velocity was in feet per second, so this will be in feet per second squared for each of them. So again, this is just using the fact that the acceleration is the derivative of the velocity, and then we had to take the derivative of the acceleration because that's the thing we were trying to maximize or minimize. That's all for today's video. We'll see you next class period.